Hi all. So today we would like to see this coding problem of linked list find the loop. So we need to find the where is the loop and we need to return the node where the loop is present in the given linked list. Say we have been given a linked list like this 0 1. So this is single linked list 3, and we have been given like 4 5 6 7 8. Yeah, so there is a loop present here. So what is a loop? Basically, generally the tail node should actually reference to the null pointer. But if the endpoint or the last node of the linked list points to some other element in the linked list itself, then we consider it as a loop. Okay. So how to approach this problem? How to find this? And we need to return this actually the node itself, not the value, the node itself. So how to solve this? So the theoretical part would be like, say for example, we can basically we can do like just iterate through the whole linked list, save it in a hash table or something, and so we started iterating the linked list and we started storing in the hash table, and we have stored this 3 4 5 6 7 8, and we come again this 3. So whenever we found that 3 is already stored, we will just return that node. But that is actually that is not optimum way, because we are utilizing a hash table which is extra space for this problem. So we can do little bit more optimally without even storing anything. So how can we do that? We can do this kind of linked list problem using two pointers method we can think. So just initialize the two pointers here, first and second pointers as the head, and what you need to do is you move the first pointer by speed like one step, and second pointer by two steps. So this is I am doing like theoretically because I want to tell one statement here. Okay, so we initialized the first two pointers, like first pointer and second pointer to head, and we started moving the two, like the two pointers. This is first and second. Move first by one step, move second by two steps. We will calculate something, we will derive out of this something. We will see that. So we started like moving the first pointer uh, first here by one step, second by two steps. From here to this is one pointer, this is 2 pointer. So second will go here. Again, move the first by one step and second by two steps. This is one step, two steps, second pointer. And you move the first by one step. This is three is the one step, and second by two steps. This is one step, two step. So yes will come here. Okay, then again, first step here, from here to here, one step, two steps, one, two. So you do this process until the first pointer and second pointer will meet each other. So they will meet each other. You will see they will meet at your point. If you go on this process. So we have moved the second pointer. Now first pointer move by one step. Second pointer move by, this is one step and two steps. Second will come here. So move by first step here. So move by second by two steps, move from one to second. Okay, so again move by one step and move by second by two steps, so one two. So yeah, you can see first and second pointers have like at, met at the same point. So this is the location we will stop iterating further. So what I'm going to tell is I will take some distance. Say for example, so from the initial element to the node where the actual loop is happening, I will call it as something as D, and I will call I will call this part from this part to here. What is the distance? Say for example x. And what we need to do, if you just iterate what is the distance from here to here, we will know what is that node, right? So how to find this? I will call this as a reminder length. And how to find this? So we will find that. So if say for example, what we have done, the first pointer we are moving at a speed of x. Say for example, second pointer we are taking two steps for every one step, so 2x. Say from this d, x and r, we will calculate the same in those variables. What is x in this case? So first pointer started from here up to here, goes here, goes here, goes here, and came here. Finally we stopped the iteration. What is this distance called? D plus x. Say what we talked, if x is d plus x, what is 2x? We already know that s will already iterate it like two times the starting point, so it will be two times of d plus x, right? That means 2d plus 2x. Okay, this is in terms of d plus x. But if I want to know what is this remainder r, I need to include uh, the distance traveled by s in terms of x r included. So I can write the s as also what it has traveled, d plus x plus r, because second pointer has traveled like this. So it came here, taking a loop, and it again taking a loop. So like this, it has come here one time, it went here, it went up to here again. This is the point. This is the, like at the number 7, it has the first pointer and second pointer met again. So it has taken twice the loops. So how can I write that? So I can write as d plus x plus r, the remainder length which I'm going to find, and again x, that's it. Then it will reach here. So d plus x, d plus 2x plus r, which is in terms of d plus x, it is equal to 2d plus 2x. So 2x remove. So d, if you solve this, like r is equal to what we got, d. This is what. So we got the remainder length, and it amazingly became equal to the d. That's what we came to know from this. So what does this mean? This length r is equal to the d from the starting point to the where the loop begins. So this is one statement. So after this, what we can do is we can just move one of these pointers, uh, starting like move the maybe first pointer and move to the starting, again to the head, and again start moving like the first pointer to from here to here, and second pointer from here to further, until you reach to this the node where the loop starts. Of course these will meet again at that point, because this length and this length are equal. That is r is equal to d. So that is the mm, that is the problem, and whenever we reach this, we just return this node. That's it, the problem is completed. So when coming to the time and space complexities, so what is the time complexity? So we have taken two pointers, so we have iterated all the way down rotated, but we need to consider only the standardized, the first pointer, because the second pointer is moving at twice the location. So we need to take the first pointer, which is moving at a slower pace, as the standard one for calculating the time complexity. Which, what is the distance it has traveled? It has just traveled the almost equal to uh, it's not almost, it has already traveled the length of the number of the nodes, that is, which is equal to, if we call n is the number of the nodes in the given linked list, then we go of n. What is the space complexity? So we haven't stored anything like hash table or anything, we haven't created. So there will not be any space complexity there will not be any space consumed, so we go off one. Okay, so we will go to the implementation part. So I will keep this. Say for example, we have taken definition. I'm going to implement in Python definition of uh, linked list loop. Linked list loop finding, and it will take parameters like just the head pointer, which we give as the give as the, like, yeah, like the head pointer. And we need to like consider um, the class, like the linked list class, like linked list class linked list, and we need to initialize the constructor, right? So definition underscore init. So it will, this will every method will take the self parameter and the other values which we are passing. So value, and for each node we enable the value self dot value, and value will make it value, and we will pass the uh, next attribute, and we will initialize that to none, because yeah. So this is the constructor, so mm, we need to consider this too. Okay, so linked list, so what we have done, we created the first pointer and second pointer, and we have mm, pointed to the head. Say for example, first pointer point to the head, uh, second pointer point to the head. And what we did, we iterated through the linked list until the first pointer and second pointer became equal. While first, so if it is becoming equal, so we need to iterate up to until it is not equal, not equal to second pointer. So one thing here, if we do the first pointer as head, second pointer as head, uh, first pointer is not equal to head, so it will be initially, the while loop will be broken at the initial stage. So instead of just creating the head, we will we will create a new nodes, like just one iteration one step before, and we move the first pointer to head dot next, and second pointer to be head dot next dot next. That's what we did after doing one iteration. So I'm just doing this because I, yeah, to avoid breaking out of this while loop immediately, seeing that head, the first pointer and second pointer are heads. Okay, so while first not equal to second, what we are doing, we are just updating the first pointer is equal to first dot next. We are just updating single steps, but for second we are updating like two steps, right? So it will be next dot next. So after breaking of this loop, we come to know that the first pointer and second pointer became equal at some point, say for example in this case 7. So at that moment what we did, we moved one of the pointers, either first pointer or second pointer, and we started pointing to the head again. So I will take the first pointer, maybe first pointer, and we'll move to head. Okay, and again what we did, we started iterating from the second pointer and first pointer until we reach at the same location. While first not equal to second, update, but we need to yeah, now we will just update like single steps now. First dot next, second, second dot next, not next dot next, because we are just updating in a single steps now. So at this, after breaking of this while loop, we will come at this number 3, which is the starting node where the is loop started for this linked list. So finally return, what we need to return, return either the first node or second node, both are equal. So that is the node which where the loop started for this linked list. Yeah, I think it is, yeah, this is completed. This will return this 3, number 3, and this will be executed in big O of n. Time complexity and space complexity, we are not using anything, so big O of 1. I think that's it, completed for this problem.